So we have completed the concept of variable, and we have seen that variables can be thought of as a container where we can store some data. And in this session we will be looking at different data types. Data type is the categorization of data items. It represents the kind of value that tells us what kind of operation can be performed on that data, or what will be the answer for a particular operation. For example, if we use addition operation on two integer data, that is 5 and 7, then we will get 12 as the output. But if we perform the same operation on two string data, that is coding and tactics, then it will append the second string to the end of the first string, which is also known as string concatenation. We will learn about it in our next video. So in Python we have total 14 data types, where we have 5 primitive data types and 9 collection data types. In this session we will look at the 4 data types, that are integer, float, complex, and boolean, and these 4 data types are also called numeric data types because they represent the numeric values. So coming to the integer data, it contains positive or negative whole numbers without any decimal point. In Python there is no limit to how long an integer value can be. Like you can declare a small number like a equals to 20, or you can also declare a long integer value like this. Python will not going to interrupt you. Now type is an inbuilt function which is used to print the type of an object. Like if we pass a within this parenthesis, then it will going to print int, because 20 is an integer number. In mathematics we have different number systems, that are decimal, binary, octal, and hexadecimals. Decimal number system has base 10, which means decimal number system has 10 unique digits that are from 0 to 9. And generally we use decimal number system in our daily calculation. And this number system is always used by Python to output an integer number. Like if you print 5 plus 5, then it is going to print 10, which is an example of decimal number system. But in Python we can also play with different number system like binary, octal, and hexadecimal. So coming to the binary number system, it has base 2, which means it has only 2 unique digits, that are 0 and 1. To store a binary number in a variable, we need to add 0b before writing the binary form of any number. Generally Python is a case sensitive language, but in this case you can write this b either in uppercase or in lowercase. It will not raise an error. Here I am not going to discuss about the conversion of a number from one system to another system. In this course we are going to use only decimal number system, so if you don't have any knowledge of this number system, then also your programming journey will not be hampered for this. For now, just remember that 1100 is the binary representation of 12 and 0010 is the binary representation of 2, and if we add them we will get 14 as output, whose binary representation is 1110. Now this binary representation are in 4-bit format. Now let me declare two binary numbers. To declare a binary number, we need to write first 0 and then b, and then we can write the binary representation, that is 1100, and again b equals to 0b and 0010. Now here I am going to declare another variable c, where I am going to store the addition of a and b, that is a plus b, and this line will print the addition. So as I have told you that Python always going to give an integer output in decimal number system only. Here I have declared these numbers in binary format, but it's showing the addition in decimal format. So now the question is there any way to represent this decimal number in binary format or not? Now to print this addition in binary format, we need to use another inbuilt function, that is bin. So we need to write bin, and then within parentheses we can pass the number whose binary representation we want to print. In our case we need to pass c within this parenthesis. And now we are going to store this binary representation in another variable, that is d. Now if we print d, it is showing the binary representation, that is 1110, which is the binary representation of 14. Here the notable point is, if I print the type of c, now it will be showing integer value, that is class int, Now I try to print the type of D, then it will be showing string format, because bin is a function which takes the integer input and then it will print the binary representation. But this binary representation is not an integer value. It converts the integer number into the string of binary sequence. And within this parenthesis, we can pass any form, like we can pass a octal number or a hexadecimal number also. And we will get the binary form as the output. But this binary form is not an integer number. It is a string of binary sequence. Similarly, we have also octal number system, and it has base 8, which means it has 8 unique digits that are from 0 to 7. Now to store a octal number, we need to add 0 O before writing the octal number, and here also you can write this O either in lowercase or in uppercase. To understand this number system, remember that 62 is the octal representation of 50 and 144 is the octal representation of 100. So let me define an octal number, that is A equals to 0 O and then 62, which means 50. Now here I am going to declare another variable, that is B, and where I am going to store the addition of A with A. And this line will print the value of B. Now again note that we have actually added 50 with 50, that's why it is showing 100, and it is in decimal form. If we want to print this in octal form, then we need to use another inbuilt function, that is oct. So we need to write oct, and within parentheses we need to pass the value whose octal form we want to print. So in our case we need to pass B. And let me store it in another variable, that is C equals to this, and then if I print the value of C, now it is showing in octal form because 144 is the octal representation of 100. This oct function is similar to bin function because here also we get output which is actually a string value, because if I print the type of phi, so it will be showing str type, that is a string type. So our last number system is hexadecimal number system, and it has base 16, which means it has 16 unit digits that are from 0 to 9 and A to F. Now to represent a hexadecimal number system or to declare a hexadecimal number system, we need to write first 0 and then X, and then we can write the hexadecimal form. To understand this, note that 5e is the hexadecimal representation of 94 and 32 is the hexadecimal representation of 50, which means 94 and 50 are in decimal form. Now let me declare two hexadecimal number, that is A equals to 0x and then 5e, and again B equals to 0x and 32. Now let me declare another variable C where I am going to store the addition of A and B, and this line will print the value of C. Actually we have added 94 with 50, that's why it is showing 144, but 144 is the decimal form. To print this answer in hexadecimal form, we need to use the inbuilt function, that is hex, and within parentheses we need to pass C. So now it is showing the hexadecimal form of 144 because 90 is the hexadecimal form of 144. 144 is the decimal form. So this function also gives the output in string format. Okay, this is a string. So this is all for this session. In our next session, we will learn rest of the numeric data types.